Alright, we are looking at our rhombus and square 5.07 lesson. Let's first explore the rhombus. The rhombus is going to be defined as a quadrilateral with four congruent sides, and the opposite sides are going to be parallel. So in the diagram to the right, you can see that it is representative of or a part of the family of quadrilaterals, and there are other quadrilaterals besides a rhombus. The plural version of this word, you can say rhombi if you want to say that, or you can just say rhombuses if you want to say that. That's also acceptable. Now, a quadrilateral is a four-sided figure like you can see on the lower left, and that particular image is usually represented as a rhombus. You can see that the hash marks that are provided are all single hash marks because it's indicating that all are congruent to each other. And we want to remember that a rhombus is also a parallelogram as well. And we've talked about how we oftentimes want to show that it's a parallelogram before it's specifically it's defined as a rhombus, but it is a parallelogram as well, which means the opposite sides have to be parallel by definition. So this is going to be our first figure that we're going to explore. And by exploring that, we have several properties that we want to reference here that are all listed out. And I'm not going to read off every single one of these angles that we've referenced here, but I am going to point some really important things out. If you go ahead and you look at like the first properties that we have here, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and then diagonals bisect each other as well. Those first properties that you see right there, that is actually true of all parallelograms. Okay, so all parallelograms have those four properties in common. So you're going to see that repeat over and over and over again. And it goes kind of in that order as well, as you can see right here. Now what that actually means is if you look at opposite sides, we have an opposite side length, for example, right here and here. But when we say opposite sides are congruent, we know specifically that all of the sides of a rhombus are congruent as well. Not just that the opposite sides are congruent, but all of the sides of a rhombus are congruent. We also know that the opposing angles are all congruent as well. Now I want to be clear about this. That does not mean that all of the angles are congruent to each other. It just means the opposite angles are going to have to be congruent, because that is true for all parallelograms. Now, something that is also true for parallelograms, if the opposite sides are parallel to each other like they would be here and here, for example, then you can recognize that those are going to be consecutive interior angles. So imagine this is a line, a pair of parallel lines, and then this is our transversal right here. Then these two angles right here are same side interior, which means they have to be supplementary to each other, which is what we're saying over there. That's also true in this context as well, because likewise, these are parallel lines, and they're being cut by these transversals as well. So we have same side interior angles are supplementary. Now, the term diagonals bisect each other. Remember, bisection means to cut in half, right? Cut into two equal halves, right? So that means that halves, plural. That means that, for example, this segment here has been cut into these two equal halves. This segment has been cut into these two equal halves. That's exactly what's happening with those diagonals. That's true for all parallelograms. Now, what's unique to the rhombus particularly is that the diagonals are going to be perpendicular to each other. So that means they form 90-degree angles. Also, the diagonals are going to bisect the angles. So the opposite angles, if you notice, they're going to be bisected. What is that getting at? What does that mean? Well, it means that this angle is going to be congruent to that angle, this one to that angle, and then this angle to that angle, and this angle to that angle. That's what that means. So that's true for a rhombus as well. I would highly recommend that you either take a screenshot or just keep a reference to this, because it has the list of all of the properties of a rhombus that you would need. So let's go ahead and take a look at an example where we have this rhombus right here, and we want to figure out the length of QR and the measures of the two angles that you see right there. So for the length of QR is located right here. We automatically know its value because all four sides have to be the same length. So that means that it's going to be 50 units. right? And I'm using that specific property that all sides are congruent to each other. That is the reason why it is 50. For the angle, the measure of angle PTS, PTS is going to be located in the middle, and we recognize that that forms a 90-degree angle because the diagonals are perpendicular, right? So remember that the diagonals have to be perpendicular in a rhombus. And then lastly, the measure of RSQ. The measure of the angle RSQ is going to equal 55 degrees. RSQ is located right here. The diagonals bisect the angles, and they actually gave us the other half of that entire angle. So the whole angle is 110 degrees. Half of it's 55, so the other half has to be 55 as well. I'm utilizing those properties to answer these types of questions, right? So all sides are congruent. Diagonals bisect each other, or excuse me, are perpendicular to each other. So we'll use this symbol. And of course, diagonals bisect the angles, right? So the diagonals bisect the angles. And remember, bisection means cut into two equal halves. So maybe pause the video and see if you can come up with the length of Vx and the measure of angle VXW. You should have arrived at 3.98 for the length of Vx, and the measure of the angle VXW is going to be 90 degrees. 90 degrees, right? So Tx is 3.98. So since the diagonals are bisected, the other half Vx is equal in length to that. So it also is 3.98. And then the diagonals are perpendicular to each other, which means that you have four 90-degree angles in the center there, and VXW is one of those angle values, so it's a 90-degree angle as well. Now let's go ahead and talk about the square. The square has all the properties of a rhombus, but in addition to that, it has four right angles. So this one is, of course, unique as well. It has to have four right angles. Of course, as you know, it's a parallelogram, so its opposite sides have to be parallel, so it's also a parallelogram. And it's a quadrilateral because it has the four sides. So you can see the diagram in the lower left represents what a square ought to look like. And it belongs to the family of rhombuses as well as the family of quadrilaterals. So it has all of the properties. So the further in the circle you are, the more representative you are of all of the properties that we have. And so again, as I mentioned, we have several properties that belong to parallelograms like these right here, for example. Diagonals being perpendicular is a rhombus property, and bisecting angles is a rhombus property. But also, another unique property that's unique to squares is that the diagonals have to be congruent to each other. So, not highlighting all the information I did before, because that's the same information, it's just it's a square now. Some of the new information, what that's actually saying is that the diagonals are actually congruent. So remember how they're perpendicular to each other. They also bisect each other, but since all of them are congruent, you can actually just use a single hash mark for each of them because that represents that all four of those lengths are the same. They're all congruent to each other. That's what that means. That's the unique property there. So looking at this example, we want to look at the measure of angle ADB. So the measure of angle ADB. ADB is going to end up being this angle right here. Since the entire angle is a 90-degree angle and the diagonals bisect the angles, I know that this has to be a 45-degree angle. Remember, the diagonal bisects the angles, so as a result, it has to be 45. So there's two things that are happening there. Number one, you have a 90-degree angle being bisected. That's how I know that that has to be a 45-degree angle. So for the length of BE, BE is going to represent this length right here. This is a 90-degree angle. All of these diagonals are congruent, so since that length is 2, that means that that length is also 2. That's because diagonals are congruent. Diagonals are congruent. And of course, they bisect each other. So I'm kind of describing the properties from that reference list. And then this last little bit right here, we want to figure out what this particular length is right here. We want to find out what the length of BC is. So did you notice that we have this right triangle? I'm actually just going to cut a fourth of that square apart. And we have these two lengths right here, and we're missing this length, which we usually can refer to as C, but also it's the length BC. So we're missing that length, and so one way that we could find it is by using the Pythagorean theorem. We know that we can take the lengths, square lengths of the legs, and we can add that together. And then we can take the square root of that to find the length of BC. Now for the time being, we could just approximate that value, right? We can say that's going to be 2.83, and that's going to be, approximately equal to BC. Okay, so in this particular case, you might want to pause the video and see if you can determine the different measures of these respective angles. You should have arrived for GJH at 90 degrees. That angle is right here, so it's a 90-degree angle. We should have arrived at 45 degrees for GHJ. So GHJ is going to be this angle right here. That's half of 90, so that's 45 degrees. And then lastly, you should have had 4.24 for the length of JG. So in this case, we are told that the hypotenuse is 6. So you have this right triangle where we actually are told what the hypotenuse is, but we don't know what these two lengths are. So we can use the Pythagorean theorem to determine that length. So the x squared plus x squared equals 6 squared. 2x squared equals 36. If you divide by 2, you get 18. So you're going to be taking the square root of 18. And the square root of 18 is approximately 4.24. So that's another case where you're using Pythagorean theorem, but we're missing one of the leg lengths. So make sure you understand the properties of each figure, right? We want to make sure we can select all that apply here. So opposite angles are congruent for both of these. Consecutive angles are supplementary for both. Only squares have 4 right angles. Opposite sides have to be parallel for both. Opposite sides have to be congruent for both. And they both have 4 congruent sides. It's just the square is very unique here with this particular one, right? Because rhombuses don't need to have 4 right angles. Okay, so looking at the last example, I recommend you utilize the Desmos graphing calculator or GeoGebra calculator to help you determine the value of or answer the many questions that we could ask you in classifying the figure in the coordinate plane. I also recommend you watch the Desmos graphing calculator video that I have created for this particular unit that can help you and assist you and walks you through how to utilize that to answer questions related to coordinate geometry. And so this problem here is kind of already plotted on a graph that we see to the right. And imagine we go ahead and we go to Desmos and you type that in. We want to figure out what type of quadrilateral it is. So one of the ways that you can do that is you ought to make sure that it's a parallelogram first, typically. And that just means that anytime you're looking at a quadrilateral, if you want to classify it, you can classify it as a parallelogram first, usually by checking to see that opposite sides have the same slope, and then you can classify it as a rhombus if it has one of the unique properties that a rhombus is supposed to have. So, are the opposite sides all the same? Are the diagonals congruent? Or rather, are the diagonals perpendicular, I should say. Let me be clear about that. And so we can do those types of things with this problem here. Let's first explore the slope of the opposite sides. I'm going to go ahead and you can use rise over run as an example. That slope I'm just going to write right here. It went up 1 and 3 to the right. This one went up 1 and 3 to the right. This one went, it's just red. This one went down 1 and 3 to the right, so that means negative 1/3. And this one went down 1 and 3 to the right, so that's negative 1/3. So in this case, I've already kind of done a little checklist for myself. I know for a fact it is a parallelogram, so I can then proceed to classify it as a rhombus at this point because the opposite sides are, opposing sides are parallel. That's what I was testing there. because the opposing sides have the same slopes. So in order to tell if it's a rhombus, there's two things you could do. You could use the distance formula to determine the lengths, of course, but there is something you can do that's probably faster, and that would be that if this really is a rhombus, you could check the diagonals. The diagonals are supposed to be perpendicular, right? And we talked about this way back in, I think it was Unit 3, where you can show that two lines are perpendicular if they have opposite reciprocals for slopes, right? So you have BD and AC as two lines, right? So the slope of, AC is going to be, well, 0, because you have 3 minus 3 over 3 minus negative 3, which is 3 plus 3. So you just have a slope of 0, and that makes sense because that's a horizontal line. It has no incline, no gradient. And then you have the slope of BD, the other diagonal. Now, the y values are 4 and 2, and then you have 0. The problem with this is that you get 2 over 0. That's undefined. That's an undefined slope. But an undefined slope and a slope of 0 are going to be opposite reciprocals of each other. That's guaranteed every single time. So in other words, vertical lines and horizontal lines are going to be perpendicular. So this is going to be a rhombus. And we know that we have opposite sides are parallel and diagonals are perpendicular. Now, could you show that opposite angles are congruent as well? Yes, you could do that. You could show that opposite sides are congruent as well. That would also verify it's a rhombus, but you only have to show one property that a rhombus has to have after you've already shown it's a parallelogram to justify that it's a rhombus. This is actually enough information to prove that it is in fact a rhombus. Okay? Because if it wasn't a rhombus, those diagonals would not be perpendicular to each other. They just would not be. And therefore it wouldn't be a rhombus. So I can make this assertion based off of this information. That would be an efficient way to do that. Okay, so you have your exit ticket. Your exit ticket here, you have a rhombus provided, and they're giving you angle values, MNT and ONT. MNT is right here, ONT is right here. Remember what we talked about? One of the properties of a diagonal. What does a diagonal do to these two angles here, right? What does it mean about those two angles? What does it do to the entire angle, actually, that you are looking at? My apologies, my hand hit the wrong button there. And then the second question, you have parallelogram ABCD, has vertices provided. I would recommend that you use Desmos or GeoGebra on this type of a problem so that you can visually see it. And then you can try to classify it just like we have been in the past, right? You can go back to Unit 3 notes as well, because in that we also talked about how you can classify rectangles as well, but we'll talk about that going forward. And it could potentially be none. Don't forget that that's the case. And then lastly, what is the measure of angle ABE in square ABCD? So ABE is going to be this angle right here, ABE. So we talked about what happens to that specific angle. We know this angle right here. What type of angle is that? And then what do you see that's highlighted in green that can help you identify what that degree has to be? What are the diagonals doing to the angles inside of a square? So that right there is going to represent your lesson for 4.0 or 5.07.